Dark matter, black holes, parallel universes, astrophysics continues to intrigue and be more challenging. Neil deGrasse Tyson, director of the Hayden Planetarium, has teamed up with two of his fellow professors at Princeton University, Michael Strauss and J. Richard Gott, to clear up the confusion. Their new book, Welcome to the Universe, an Astrophysical Tour, explains the latest discoveries in their field, and it is published by Princeton University Press. I'm very pleased that it has brought Neil deGrasse Tyson and Michael Strauss to our show today.
Thank you.
Welcome, and welcome back, Neil.
Hey, thanks for having me back.
Very happy to be here.
Along with J. Richard Gott, both of you teach an introductory class at Princeton on astrophysics. Isn't that course designed for non-science majors?
Yeah. Oh, yeah.
So was it an unusual decision for Princeton to devote so much thought and three top professors for students who probably never take another class in their department?
That is the goal. If you know you have students for just one semester, and that's the only time they're going to learn about the universe, and for some of them it might be their only meaningful science class, then you got to do it right.
In a recent survey, the National Science Foundation discovered that 1 in 4 Americans think the sun revolves around the Earth. Did Nicholas Copernicus establish that the Earth revolves around the sun in 1543?
Quite some time ago.
Why would that still be a problem?
Well, we educate our students, and we educate the world in our astrophysics. Not everyone pays attention. One of our challenges, of course, is to try to get that information out there. And we do so by teaching courses. We do so by radio shows like this. We do so by writing books.
And then there were some creationists who believe that the world was created fewer than 10,000 years ago. Some refuse to say that there was such a thing as evolution. Are you concerned that so many Americans continue to know so little about science?
I have a slightly unorthodox view on that. It doesn't matter to me if you reject all the science that has ever come since Copernicus and before, provided you are not put in a position of power to legislate it.
But we have some people in Congress who say there was no such thing as evolution.
That's where it becomes a problem, because then they want to create legislation that affects us all, based on a belief system that is objectively false. And so in a free country, you can believe whatever false things you want. But if you are then elected to power and you have power over others in a pluralistic land, then it just becomes dangerous.
Are the problems, did they begin with the way that science is taught in schools?
Science is a process. It's a way of thinking. It's a way of tackling the problems that are around us. And that's one of the things that we as educators very much want to try to get across.
And when you were writing this book, did you think of it as something like a textbook or a popular book about science suitable for a layperson?
Yeah, that's a great question. I think because it emanates from the class we taught. Each of us took a sector of the universe. It was fun dividing up the universe that way. So I was stars and planets and things, and Michael Strauss was galaxies, and J. Richard Gott was large-scale universe and relativity, and we went in that sequence. So we took the best parts of the course that we knew would have good flavor interest for a reader and put it in a book.
Well, since I'm not exactly sure which one of you wrote one, I'm just going to throw out questions.
Please go ahead.
You answer.
Mike, you can take them all. I'll just sit here.
Early in the book, you point out that the days actually don't get shorter in the winter and longer in the summer, although we've heard that throughout our whole life.
Yeah, it's a little bit of that. Half of that is semantic, because I remembered hearing it as a kid, days get longer in the summer, and I thought to myself, isn't every day 24 hours? What is that? And so, so there's that issue. Okay, of course, all days are the same length. Then how about sunlight? The hours of sunlight get longer in the summer. Actually, they get shorter in the summer for a very simple reason. And
after the summer solstice, they start getting shorter.
Yeah, the summer solstice is the longest day of the year, and we call that the first day of summer. So if the longest day of the year is the first day of summer, every subsequent day in summer has to be shorter. It's that simple. And the opposite is true with winter.
So we really should be saying that the days get shorter in the fall and get longer in the spring.
Yeah, or it gets shorter in the summer and longer in the winter. It spends 6 months getting longer and 6 months getting shorter. Yeah. Yeah, so little things like that, those are put in there just to confront what might be things you otherwise misthink, and then cosmically. And so there's huge doses of that throughout the book that keeps the book relevant and interesting.
Aren't we still unsure about a lot of the things that you're writing about here? How many stars there are? In fact, how many galaxies there are?
One of the things that makes astronomy so much fun is just how ignorant we are about the universe. The universe is a very big place, and in some very basic sense, we've just begun to explore. And
Michael, speak for yourself about being ignorant about the universe.
No. Okay. He runs the Hayden Planetarium. He knows everything.
But there's basic questions, as you just hinted, about fundamental questions about what the future of the universe might be. Will it expand forever? Will it the accelerated expansion that we're now seeing continue forever?
Well, you mentioned the expansion.
Yes.
Until not all that long ago, it was thought that the universe would in fact implode, wouldn't it?
Well, there was a time when we were trying to find data on that, but I think Michael can confirm this.
Well,
I think there was never a time where the data said we would recollapse.
But the conventional wisdom is you have this big bang, everything then moves quickly apart, and then in time it slows down more and more and more, and then it would go in the other direction.
People wanted that to be true because it would bring closure to the end, the cycling universe.
Makes a neat story, as it were.
It was philosophically more appealing than just, by the way, this is a one-way trip, and it had a beginning, and the end is in the infinite future. That brings people existential angst that is accompanied by discomfort. So yeah,
well, how did we discover that it's expanding and speeding up?
Michael will tell you that in a minute. The backstory to the collapse is that Einstein's equations that tell us how we can expand allow there to be a collapse. You just change the sign of one of the terms, and the equation works perfectly fine. So it is a legitimate solution to Einstein's equations. It's just not the universe we actually live in.
Right. So we observe galaxies. We see them moving away from us. We actually observe the expansion of the universe directly, and that goes back to 1929 with Edwin Hubble. And now, more recently, as we've done more precise measurements, we've seen that expansion is accelerating.
Did Einstein predict that?
Einstein predicted a version of that. He wrote down a version of his equations that allowed for this accelerated expansion. He himself didn't believe it and later called it the greatest blunder of his life, but we find ourselves resurrecting those ideas in a slightly different context to explain the acceleration.
In fact, Einstein's greatest blunder was saying that was his greatest blunder.
Yes. Yeah, Einstein thought he'd made a number of mistakes, and they all turned out to have not been mistakes.
That's how you know you're badass, that even when you're wrong, you're right.
Right.
My guests are Neil deGrasse Tyson and Michael Strauss, two of the three authors of a new book called Welcome to the Universe, an Astronomical Tour, published by Princeton University Press. This is WNYC and WNYC.org. I'm Leonard Lopate. So we still don't know how many stars there are out there, how many galaxies. Can there be an infinite number?
We talk about the observable universe, that part of the universe for which light has had enough time to reach us. And within that boundary, there's something like 100 billion or 200 billion galaxies, and each galaxy roughly having a few 100 billion stars. And we go through these numbers in the book.
And do most of those stars have their own planets?
We are now convinced that is the case. New observations are indicating that.
Just because we're on a planet, do we believe that all life needs to be on a planet? Could there be life on a moon or an asteroid?
Let's assume that we're not going to find life on a star. Let's just start there.
Too damn hot.
Too damn hot. It's too damn. It's so hot you vaporize.
Are they all pretty much the same?
No. Some are. No. The sun is kind of in the middle. And stars come much cooler and much, much, much hotter. So, and by the way, that's a fascinating question because the temperature of the star determines the right distance for a planet to host liquid water. So in this inventory of planets that we've been trying to assemble over the recent years, our community, that we give special attention to those planets that have the right distance around their host star. And by the way, it wasn't until
you call that a Goldilocks zone.
Goldilocks
Yes,
zone,
exactly.
exactly. The original term was habitable zone, but that was too many blunted syllables following one another. Just the Goldilocks zone works just fine. And so what we learned in the Voyager Grand Tour of the planets, where we got close-up views of the moons, previously just sort of dots of light. Why would anyone care? We start looking closely at the moons, especially of the Jovian planets, Jupiter, Saturn, Uranus, and Neptune. They are stunning in their diversity. So I think right now the net that we cast in search for life needs to include the conditions on planetary moons as well as planets themselves.
Are there any theories as to why the planets are all so different? You would think that when they were all created, either coming off of the sun or being captured by the sun, that they'd be pretty similar.
Well, a lot has to do with how far away each star is from. Each planet is from its parent star, and we thought we had an understanding of that until we started discovering planets around other stars, which completely violated our simple assumptions about how our own solar system formed. And so we now realize that the world of planets is a far more interesting, complex place than we used to.
Yeah, so
think.
it's part of mystery how you can have planets in the same family that are so different from one another. And we would also learn by studying other solar systems that you can have planets that migrate from one close orbit to a distant orbit into a close orbit by flinging other planets out. It's quite a violent place, this formation of solar system scenarios. And
so we're lucky to be in a fairly stable system?
Exactly.
That's
in fact, most planets that have ever been born may have been cast asunder, orbiting aimlessly amid the stars. And we call them, what's the latest, vagabond planets?
Yeah, vagabond planets. It's a fine phrase.
Yeah. And if they have any leftover heat within them, as Earth does from our core, in principle, you could sustain life on planets even though they themselves are not in orbit around a star.
Now, you mentioned...
And we go over all of this in the book, by the way. It's all there.
Well, that's why I'm asking these
questions. And they're not just statements. It's how did we come to learn that this is true? The whole backstory is in this book, which is what distinguishes it from, I think, most other books you'll find on the shelf.
You mentioned the presence of liquid water. Can there be life without liquid water?
That's always the question, life as we know it. And life as we know it here on Earth indeed requires liquid water, a solvent in which the various chemical reactions can take place.
When we see movies about life from other planets, they always have eyes, ears, mouths, arms, legs, shapes that we can recognize from our own planet.
Yeah, because they're paying an actor,
in that zipped-up suit from Star Trek. Yes.
From the Screen Actors Guild, there's scales. But a point about liquid water, I'm reminded of a comic, I think it was in the New Yorker, where there's an alien who crash lands in his flying saucer in the desert, and he's crawling along the desert, tongue dripping out. He says, "Ammonia, ammonia." But it turns out water is hugely common as a molecule in the universe, just for starters, and not
because
only
they all have hydrogen and oxygen.
Hydrogen and
two
oxygen, exactly.
Very common elements. Two of the four most common elements in the universe. Not only that, we are carbon-based in our chemistry. So organic chemistry is carbon-based. And some creative science fiction folks said, "How about silicon?"
Star Trek had it.
Exactly. Silicon sits right below carbon on the periodic table of elements, and if you might remember from your high school chemistry, all the elements in a column make similar families of molecules. So if you can have life based on carbon, why not swap out the carbon atom, put in silicon, and then create life based on that? You can do that in principle, but in practice, there's 5 times as much carbon in the universe as silicon. So you don't need to appeal to these exotic ways you might make life.
And doesn't carbon bond better than silicon?
That's right.
It bonds hugely.
More interestingly. More complicated ways. And life is complicated.
Yeah. If you had to pick an atom on which to base the complexity and biodiversity of life, it would be carbon. There's some silicon bonds that are so strong that they never break, and so you don't get to experiment chemically.
Right.
Now, we can't see most of the planets out there. We just see the result of their movement.
There's several ways to do it. The Kepler satellite actually looks for the shadow or that the planet transiting in front of the star casts. That is, what you see is a slight diminution of the light of the parent star.
I'm going to take a little break here, and we'll talk more about the subject at hand, Welcome to the Universe, an astrophysical tour written by J. Richard Gott and the two gentlemen in my studio, Michael A. Strauss and Neil deGrasse Tyson, published by Princeton University Press. Stay with us for more. We are back with Neil deGrasse Tyson and Michael A. Strauss, two of the three authors of a new book called Welcome to the Universe, an astrophysical tour, the third being J. Richard Gott. It is published by Princeton University Press. All of them teach at Princeton University. Michael, how far away are the stars that we can see?
The nearest star is about 4 light years away. Remember, a light year is 10 trillion miles. 10 trillion kilometers, excuse me. So the distances are vast by human standards.
Do we know how long stars live, or are some of the stars that we see no longer even in existence because of the time it takes for light to travel?
When we look within our own Milky Way, the distances are only a few tens of thousands of light years, and so that's not very much time in astronomical terms. But we can see distant galaxies whose light left it 8 billion years ago, or even more than that.
And as a result, can we see stars being born? Are stars still being born?
Oh, yes, absolutely. There are regions in the Milky Way where stars are being born right now, and it's a process that we very much are trying to understand. And
it's fun. It needs a special telescope to see through the gas that enshrouds the birthplace, and so it's quite a triumph of modern astrophysics that we have even gained access to these previously secret places in the galaxy.
We no longer have the Hubble telescope, so
we certainly do. It's still flying.
Is it? But it's not. It's kind of been abandoned.
No, not. I mean, it will end its life, but it's still very much active as we speak.
Are there plans to do something that would create one that will be able to see even more?
Well, I mean, after we drop Hubble into the Pacific,
yeah.
There's the
reason I ask is we had Mike Massimino here. He's the last astronaut to actually work on the Hubble.
Yeah, he's a good friend, and we love him to death, Mike Massimino. So in the Hubble telescope, there's a whole, I don't want to call it a replacement telescope, but it's another generation of space telescopes called the James Webb Space Telescope. He was the head of NASA during the Apollo era, the parts of the Apollo era. So it's a good homage to that time in NASA's golden age, as they call it. But that telescope will be vastly more powerful than Hubble. Vastly.
You were here sometime in the past to talk about Pluto. And
don't get me started. Don't hold me back.
Well, it was discovered in 1930.
Yeah.
And it was thought to be much larger than it actually
turns out to be. So it was assumed at the time, because of how we were searching in other ways for it, to be about the mass of the Earth. So if you look at the New York Times Discovery article, the article on the discovery, it describes it as being Earth-size. And over the years, as our measurements got better and better, the size of Pluto got smaller and smaller because we put upper limits on how big it could be, and it got that didn't settle out until like when was it, the early 1990s,
with the Hubble Space Telescope.
Well, there are a couple of other measurements. So measurements of Charon in orbit around it. So Pluto is 1/5 the mass of our moon.
So what would you call it? An asteroid?
Well, we have official terminology for it now. Yes, it did get demoted. So just get over that fact.
And people have got really upset with it.
Yeah, especially third graders. Yeah, I think so.
Well, they had to learn a whole new mnemonic.
Yeah, so you got a problem with that? You had to learn something?
The new mnemonic is, my very excellent mother just served us nachos.
Yeah.
It used to be nice, what was it?
Nine
Nine
pizzas.
pizzas.
9 pizzas. If you go really far back, it used to be 9 prunes.
Wasn't Uranus originally called George?
Yeah, planet Uranus. Well, it was discovered by Herschel, who was the first person to ever discover a planet, because all the previous known planets were just visible to everybody. You didn't need a telescope, and so and the names we adopted were the ones used by the Romans. So they're the names of Roman gods: Mercury, Venus, Mars, Jupiter, Saturn. And so he discovers a planet. No, there was no tradition in naming them yet. no official written tradition. So he named it after his principal funder, which was King George. So for a couple of decades, if you look in the books, the enumeration of planets was Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George. And so
It doesn't somehow right.
so we fixed that. All right. So we brought it back into the nomenclature, and as an homage to the Brits, who, give them credit, they found the thing in the first place. The moons of Uranus are named for fictional characters in Shakespearean literature. And it's the only exception among the planets that are out there.
Is that what inspired you to suggest that we call dark matter Fred instead?
Neil, did you really say that?
I did. Forgive me. I did say that. No, there's dark matter and dark energy, two profound areas of ignorance in our field. Michael, accounting for how much of our ignorance in the universe? What is it?
They together represent about 96% of the mass density of the universe, and we do not understand either piece of it. Combined, coming to 96%.
So I said, since we don't know what these are, we don't have a right to assign a name to it that gives you the impression it could be what the name is. Right. We don't know that dark matter is matter. We don't know that dark energy is energy. So I just said, call them Fred and Wilma. And then there's no implication of what it could be. Right. Freeing your mind. I've had people say, could dark matter be this kind of matter or this other kind of matter? See, they're being forced into certain pathways of thought, and the greatest of scientific thinking has no such constraints.
A listener tweeted about the 234 planets that some sources claim are beaming out messages.
There are no such planets that we're aware of that are doing so.
Tesla believed that he was communicating with Mars at one point.
Yeah.
This incredibly brilliant man who gave us alternating current and other things, fluorescent lights, etc. He believed that we could communicate with.
Yeah, he went a little too far. By the way, he is duly respected in the community of physics. There's a unit of electromagnetism named after him, and you can't get a higher honor than that. And a car, indeed. Yes. So I've got no gripes with Tesla, but I think his imagination went beyond the reality at a given point in his life.
But haven't we seen all sorts of situations where the imagination of science fiction writers and the like have turned out to actually have some truth to them?
Well, absolutely. So Jules Verne is a classic example of that, who foresaw a great deal of things, submarines and trips to the moon and various other things, and of course didn't get all the technical details right. No one has that perfect foresight, but there are many such examples.
I would add, though, that many of those foresights were technological and not scientific.
That's fair.
So the science is less likely to come out of science fiction than an interesting bit of technology that we dream and long for, like the flip phone, deriving basically directly from the communicator on Star Trek. And I interviewed William Shatner for StarTalk recently, and he told me that an engineer at Motorola, the TV show, an engineer at Motorola gave him the very first StarTAC flip phone that he now has in his possession, inspired by. Now we're even past that. Okay.
Of course, we couldn't predict certain things. HAL in 2001 on the computer on the spaceship was huge. By 2001, it would have been a very small thing.
Yeah. Bigger was not better with regard to computing. That's a perceptive point.
A listener wonders if there's climate change in other parts of the universe or just on Earth.
Only on planets where there's no evidence of intelligent life.
But that's Earth, right?
Exactly. I mean,
Michael, what do you?
Well, the Earth, we live in a sea of atmosphere, and one of the reasons that we have climate change is because the atmosphere is changing. We are blanketed by that sea. It gives us the greenhouse effect. And so if the atmosphere changes, yes, indeed, the climate will change. And that does happen on other planets on long time scales for geologic reasons, for example.
They may very well have volcanic action.
For example.
A listener asked about Planet 9 on the edge of the solar system.
Yeah, it's an interesting...
What's led to that conjecture?
Yeah. It's a fascinating current news story, scientific frontier, where the same guy whose Twitter handle, by the way, is called Pluto Killer, just FYI. So I'm not, I may have been an accessory, but he has admitted it. So this is Mike Brown out at Caltech. He and his team have looked at the orbits and trajectories of small icy bodies in the outer solar system in what we call the Kuiper Belt, where you find Pluto. And he sees that you cannot explain their behavior based on all the known sources of gravity that's out there. And so they're inferring an object too far away for its light to be detected yet.
Yet is a key word.
And so ideally they got to tell us where to look and how dim it might be, and then we tune the next generation detectors to try to find it.
And that search is going on right now.
It's going on right now. And it's called Planet 9. It's a noble exercise in mathematics and physics predicting reality.
Can you tell us about the large synoptic survey telescope that's currently in construction in the Chilean Andes?
Yes, so this is
do we still trust earthbound telescopes?
Oh, very much so. What a big telescope. You can build big telescopes on the ground. You can build telescopes with a very large field of view. And so we're still in a stage in astrophysics where the mapping exercise, the exploration exercise, is really a fundamental one. And this telescope will map the universe, take pictures of the sky, and do so repeatedly to look for example, Planet 9, should it exist, and other phenomena in the universe.
And is it significant that it's in the southern hemisphere?
That was a big debate. Here on Earth, we can only see a part of the sky at any given time or from any given location, and so we always have that choice. The southern skies, the Milky Way is much more dramatic there, and so if you want to study the Milky Way, for example,
as I did for my PhD thesis.
That's right.
That's where we met. I think we
first met in Chile.
Yeah, in the mountains of Chile.
That is correct. That is correct. Just about 30 years ago.
Don't say that. Yeah, I don't remember.
My guests are Michael A. Strauss and Neil deGrasse Tyson, co-authors with J. Richard Gott of Welcome to the Universe, an Astrophysical Tour.
Leonard, one quick thing about the Large Synoptic Survey Telescope that I think is underappreciated, and Michael, correct me if I'm wrong. Yeah. This telescope will have a baud rate. It will have a data acquisition rate that is higher than any telescope before. And embedded in there is its ability to repeatedly observe the same part of the sky. And the most interesting things we've ever found in the universe are things that change on like a human timescale. And this would be able to find things that change on daily.
Right,
even.
Exploding stars, those moving asteroids, the moving Planet 9, should we exist.
Yeah. So it can find things that go bump in the night.
Another thing that makes it very exciting is that those data will become public to the world essentially immediately. So school children can look at the data taken last night and find the supernova and be literally the first human being on Earth to see it.
It all began with the Big Bang. Is our Big Bang the only one? Do we know?
It's a shame we don't have J. Richard Gott here, because this is his favorite topic to talk about. Our current understanding, which is far from complete, is indeed that the Big Bang may be part of what is called a multiverse, as we describe in the book, where there have been multiple periods of expansion in different regions, and these different multiverses may be going on as we speak at distances that are unobservable.
An infinite number of universes?
Possibly infinite. And the most intriguing part of this is at the quantum level, at the genesis of each of these universes, there is the likelihood that they have slightly different laws of physics that apply. And that makes it scary and intriguing what it might be like to visit such a universe.
We have no idea how to get there.
We would never do it.
Well, no, I don't know. I'll never say never, except when I say never. But if we somehow find a way to tunnel out of our universe and visit another one, bring something else with you to see what happens to it when you stick it through the portal.
What about the attempt to come up with the unified theory? Is string theory still being considered seriously?
Yeah, it's we have laws of physics that describe the nature of elementary particles and how they interact and the various forces. And scientists are very interested in seeing how it all fits together. And string theory, as you mentioned, is one such approach, still the most promising approach, but we're still far from a final answer there.
What about the concept of wormholes? Would that allow us actually to go to those other places?
I love me some wormholes. Who doesn't love a wormhole? But Rich Gott, again, this is his expertise, is manipulating Einstein's equations of gravity and space-time to determine what is possible and what is not. What we do know about wormholes is that the amount of sort of mass energy you need to warp the fabric of space to create one is not only huge and far beyond anything we can foreseeably have access to, but the hole you open up is unstable. And you can open it and try to crawl through, and they could collapse on you, and that's got to be ugly.
And now we're talking about what happens when you enter a black hole.
Yeah,
for a long time, there was a big debate over whether there were such things.
No, black holes really do exist, and one of the great discoveries, indeed, in just the last year, was the discovery of a pair of black holes orbiting around each other. As black holes orbit around each other, they send out what are called gravity waves, which we can actually detect by the distortion of space and time that we see in detectors here on Earth.
Yeah, they're like ripples on the surface of a pond, and they emanate. Except on the surface of a pond, they're moving at sort of the speed of waves, and in water, here they move at the speed of light. And it was just discovered by the LIGO collaboration. And how far away was that?
About
30 million light years?
400 megaparsecs. So that's about, about
Earth to Michael.
a little over a billion light years away.
Oh, okay.
Something like that.
Now, Neil, a listener tweeted, "Is it true that you're working on a novel?"
Aren't we all at some time in our lives? No, I don't claim the writing expertise to tell the kind of stories that great novelists, even bad novelists, tell. So I think about it, but I don't have the time right now. And maybe one day when I'm sitting in a rocking chair on a beach.
But meanwhile, you're doing a thing on the Cartoon Network called The Regular Show.
No. I get called for. They all just cameo. I get phone calls to do cameos of myself or voice other characters. I'm flattered they like my voice, but I only agree if it's got real science in the thread.
Will the both of you be traveling west next August for the big solar eclipse?
One doesn't have to be in the west. It crosses the entire United States.
Oh, we could see it here.
Well, you want to travel a little south of New York City.
Yeah,
but yes.
It landfalls in the Pacific Northwest and comes off down in South Carolina, North Carolina. Yeah. It's America's eclipse.
Yes.
Well, we are eclipsed right now because we've run out of time. Michael A. Strauss, Neil deGrasse Tyson. The book, Welcome to the Universe, an Astrophysical Tour. It's published by Princeton University Press. Thank you so much for being on our show.
Thanks.
Thank you. I'm very happy to be here.
Published by Princeton University Press. Thank you so much for being on our show.
Thanks.
Thank you. I'm very happy to be here.